Man has studied the oceans for centuries. Human nature drives us to be curious about our environment, and over time, advances in technology have enabled us to explore further, look deeper, and discover more. Early scientific expeditions, such as the Challenger expedition in the 1870s, relied on rudimentary measurements of seawater depth and temperature, and visual descriptions of sea life dredged up from the depths in a bucket. Fast forward a century and a half, and ocean observing has evolved. It's now a complex, multidisciplinary science that uses cutting-edge technology such as satellites, ocean observatories, and networks of probes to monitor the world's oceans and create up-to-the-minute forecasts of ocean state, weather, and atmospheric conditions. Autonomous and robotic vehicles can map the seabed in graphic detail, record high-definition images of marine life, and even take samples of the seafloor in order for us to learn more about the marine environment and its inhabitants. Today, science has moved on from innocent curiosity to an urgent need to understand the many pressures on our oceans and to help devise ways to manage or mitigate them. These pressures range from global-scale problems such as climate change and ocean acidification to more region-specific issues such as overfishing, pollution, and resource extraction. Understanding and predicting how our oceans respond to these issues both now and in the future requires massive amounts of data from a variety of sources.
Today we're developing techniques that can very intelligently and adaptively sample the oceans, and this is really going to radically transform our knowledge of the ocean, the volumes of data that we have, and therefore transform the way we're able to forecast and predict and understand the global ocean.
Of course, this task is much bigger than a single research organisation can address alone. The only way that these big issues can be tackled is by working together and sharing data, something that sounds obvious but in reality is difficult to achieve. Usually data are collected in a particular region or over a limited period of time. Once the dataset has served its initial purpose, it is often archived away, out of the reach of others. Information about the marine environment is expensive and time-consuming to collect, but if it is not readily available to the wider community of scientists, engineers, industry and policymakers, then it becomes worthless.
The biggest challenge really facing data collection is the fact that we're gathering it from all different places in all different ways, and we're storing it in many different formats. The key is to get it into a common format. The key is to bring it together in one place. One of the big issues is that we all tend to put it onto our own laptops and then we take it away with us. The key is that when we gather data, we want it in a simple format. We want it very well categorized. We want the metadata to go with it, and we actually want it in a way that it can be used in years and years and years down the line.
Data is held by hundreds of different organizations. We did a study, and this found that it was held by hundreds. The data was difficult to access. You couldn't find the data. And then once you found it, it was difficult to put the data together because they were of different formats, standards, baselines.
For marine data to have maximum value and impact, it must be freely accessible, quality controlled and easy to find. With these goals in mind, the European Commission in 2009 initiated EMODnet, the European Marine Observation and Data Network. EMODnet is a community of more than 100 organisations working together to observe and measure the oceans, process the data according to international standards, and then make that information widely available. Not only does this mean that users can access marine data quickly, they can also be reassured that the data is accurate and quality controlled, and the different data layers can be used together.
We've got three aims of EMODnet: to reduce the costs of people working offshore by making it easier to find data. Second, to promote new activities, create innovation by allowing people to do what they couldn't do before. And thirdly, to reduce uncertainty in knowledge of the sea.
Data are hard to collect at sea, and they are, to date, difficult to have access to, especially if you're looking for data of different disciplines, if you're looking to combine chemical data with physical data and biological biodiversity data, for example, it's very difficult to gather your data and to have them ready for analysis.
Though it's not just research scientists that need access to information about the ocean, various public authorities have responsibility for managing the marine environment, from protecting its natural resources to ensuring the safe and responsible operation of maritime industries such as shipping, aquaculture and renewable energy. To do this, they require reliable, accurate and quality control data to make informed decisions.
Data collection is crucial to foster a European knowledge on the European seas. It's the basis to create information and from there to create knowledge. Without knowing what is there, there's no policy makers that can provide efficient policies to exploit our oceans, but also to preserve our oceans.
In Europe, efforts to monitor and protect the marine environment are underpinned by the Marine Strategy Framework Directive, which aims to ensure our oceans are healthy and productive. For this to be effective, accurate and up-to-date information must be readily available about the sea, its habitats and ecosystems, and the pressures they face from human activities or global threats such as climate change.
For the Marine Strategy Framework Directive, marine knowledge information is absolutely essential because the whole thing is based on an ecosystem-based approach, which means that we have to integrate all sorts of knowledge and try and come to policy decisions that affect the marine environment. So all sorts of knowledge, all sorts of data is really important, and then having an access to that data in a way that you can do assessments and build up your knowledge quite easily is really important. So EMODnet will be an essential tool for anybody wanting to get data on things such as biodiversity, so it's an important issue for all of us.
Marine data is also important for the commercial sector. In Europe, the so-called blue economy represents about 5.4 million jobs and generates a gross added value of almost 500 billion euros a year. Having better access to a wide range of marine data will help stimulate new maritime industries, improve the efficiency of existing operators and foster new collaborations. But this can only work if more organisations join the effort to improve access to data.
When we started with EMODnet, there was some reluctance of some organisations to join in because they wanted to hold their data tight so that they could claim a monopoly on the added value services. But now they've realised that by putting their data together with the data from other organisations, they can provide many more services than they did before.
EMODnet provides access to a range of data describing Europe's seas. This includes the shape and composition of the seafloor, the physical and chemical qualities of the overlying water column, information on marine habitats and the sea life found there. It also provides information on a wide array of human activities such as aquaculture, waste disposal and renewable energy installations, and conservation measures such as marine protected areas.
The real value of EMODnet is that it allows all users a very easily accessible database. So the investment in acquiring the original information gains great added value. All users can have it. Policymakers, industry, researchers. That's where the real value lies to me.
EMODnet has taken great steps towards better access to European marine information. But there's a long way to go to really fulfil its potential. EMODnet needs wider and better engagement from marine industry groups, government agencies and scientists. Adopting a collect once and use many times approach to ocean observing is beneficial to everyone. It saves money and effort, expands our knowledge base and ultimately will help protect our marine environment.